How is everyone today? That's good. All right, let's start with any questions. All right. No questions, I guess. Um, I got word yesterday, and I guess this was in Penguin Digest also, that we are going to be online for spring, as well as winter. Oh, let's see. Basic question: how does one get info from one end of a pipe to another? Um, you mean what's the underlying mechanism for that happening? Um, Yeah, so you'd want to dig into the actual code for Linux to see how that happens. It's an operating system thing, right? But basically, how does information get out to a hard drive when you write it into a file? Ultimately, there's a low-level system call that's made, and the operating system picks up, information saying what your request was, and then actually sends the ones and zeros to the hard drive through a driver. It's a little easier with a pipe because it's just moving stuff through memory. But a data structure is created, something like a queue, which we'll talk about in 222. But a data structure, and when you write into file descriptor bracket 1, it gets added into the back of the queue, and then when somebody wants to read from file descriptor bracket 0, the low level read code in the operating system says, okay, is this coming from a hard drive, is it coming from a keyboard, oh, it's coming from a pipe, and it finds where in memory those characters are stored and pulls them out of there. It's a pretty miraculous thing to dig into. If you have time and inclination, it's fun sort of running the debugger on Linux itself and going through some source code and trying to really track down, like, when you write into a pipe, where is that character stored in memory, right? It's stored somewhere. See if you can actually figure out where that thing is stored, and then maybe change it so that when somebody reads from the pipe, they read a different character. And yeah, but you're not actually reading and writing an array. The array in the pipe command is just being used to store the two file descriptors that correspond to the ends of the pipe. But there's always these file descriptors 0, 1, and 2 for standard in, out, and error. And with the pipe, you just get additional file descriptors, usually starting from 3 and 4. Let me see if I can find da, 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 da. So, well, let me... So I'm process ID 32029. So if you go on a Linux system under proc and go into a directory with your process ID number on it, you find all of these files associated with your current process. So IO is a file that shows how much IO has happened for this process. So how many characters have I read, how many characters have I written, and so on and so forth. There's an FD I haven't looked at these a whole lot. So here's a directory called fdinfo, and it's got some files 0, 1, and 2. Right, those may not be terribly interesting. Oh. So in this directory, right, so /proc /myprocessid/fd, there's files 0, 1, and 2. Those are symbolic links to devpts3, which is, you know, the sudo terminal that I'm currently running bash on. So when somebody wants to read from standard in, right, they open up file descriptor 0, and when they try to do a read, the system will look in here and say, oh, they should be reading from this physical device. I don't know if I can make this funky. Yeah, if you play around with this, you can change this to be, you know, a file or the output of a command or something like that, and run your ls and actually see a difference there. Or, you know, just run a piped command and look at the fd directory for that process ID, and you'll see these things mapping to something else. But the actual low-level I/O, dig into the code and see if you can figure out how that happens. And, you know, Linux, everything is a file, so if you want to do, you know, read from a keyboard and write to somebody's display, you can do, you know, fgets, and you can do printf. If you want to read from a networked connection connected to a machine, you know, on the International Space Station, you can read with an fgets and write with a printf. And the code looks exactly the same, right? It's just, you know, where that code is sending its output to. Well, it could be your display, it could be a file, it could be the input of a command, it could be a network connection, right? And it's a very sort of uniform structure from the code's perspective, which is nice. All right. So let me, before we start talking about awk, let me talk about the Service Learning Project. So as I mentioned, you know, the SLP normally starts in fall, and we didn't do that this quarter because, you know, we were still kind of new to online. So everybody got 100% for their 5 percentage points for the SLP. But we'll be starting the SLP in winter, okay? And I want to give you a heads up on what this means so that you can be thinking about it between now and the start of winter, because when winter term starts, basically the first week you're going to want to turn in a proposal for your service learning project. So I want to just kind of introduce the concept now so that you can be thinking about it. So what's the idea of the SLP? Basically, you know, you're taking classes, you're learning stuff in your classes, you're doing homework, you're being tested with tests, right? That's all great. That's important stuff. Imagine yourself, you know, you get to an interview and you're, you know, at Google or Facebook or, you know, wherever your dream job is, and you've got an interview, and the person wants to know, you know, why should they be interested in you? Why should they consider hiring you as opposed to the, you know, 7,000 other candidates for this position? Well, you can say, you know, I went to Clark College and I did all my classwork and I did all my homework and I got good grades. Well, chances are everybody else who's gotten this far in the interview process can say the same thing, right? So yeah, it's important to do your homework, get good grades, learn your material, take all your courses. That's a kind of starting point. How do you set yourself apart from everybody else who has done that? And a lot of the answer to that is through project work. Right? because projects are you know, something that each individual works on, and the way you pick a project, the way you pursue it, what you come up with in the project, what you learn while doing the project, that's where you can really differentiate yourself. And so this project-based learning is essential, not just for, you know, continuing to build your skills and so on, but also when it comes time to, you know, put together your portfolio and try to sell yourself to a company, right? Being able to say something about, you know, the independent work that you've done can be really huge. So this is part of the motivation for the Service Learning Project. So what the SLP is a year-long project, although for us it's only going to be 2 quarters instead of 3, but a year-long project of your own choosing in some area that you are interested in but not an expert in. And the goal is to teach yourself and learn what you need to do to be able to do this project. So it should be something that pushes you, something that takes you beyond your coursework, something that requires independent study, independent work, right? But hopefully something that you're really, really interested in, something you're passionate about. Because you can spend a lot of time doing this project, and if it's something that, you know, you're dreading every time that you have to work on it, it's not going to be fun, you're not going to work on it as hard, you're not going to learn as much. So we don't assign SLPs to students usually, right? We let students pick them. It can be web development, it can be, you know, Android app development, it can be game development, it can be hardware related, it can be software related, it can be almost anything, right? The hardest part of this, at least up front, is choosing what you're going to do. So so usually fall quarter is spent with students, you know, coming up with ideas, submitting proposals, we iterate on them and so on. And usually by the end of fall, you know, students haven't actually done a whole lot of work towards completing the project, but they figured out what they want to do. All right, we're going to have to pack that into winter term, but we can't spend all of winter choosing a project, because then you'd only have spring to actually do the work. And you know, a good project will take you a few months of pretty solid work to get to, you know, a nice milestone. So what I'm going to ask people to do is spend the time between now and the start of winter quarter thinking about what they want to do for an SLP. And you can, you know, send me emails, we can kick around ideas, you can come by office hours, we can talk about it and so on. But then first week of winter term, we'll talk about all this again, but I'll ask you to, you know, submit a formal proposal, probably start of the second week of winter quarter. So if you can be thinking about it ahead of time, you know, that's to your advantage. Because you really want it to be something that you care about. You don't want to just, you know, pick something because you had no idea and then you're stuck doing this, you know, for half a year. That's not a lot of fun. And you know, people will do game development, right? They want to know how to write a game, so they're going to teach themselves how to use Unity. Or they want to do something with networking. They want to, you know, take their aquarium and put it on the net so they can, like, check the health of their fish when they're not at home, right? Or whatever. You know, I had a student who made a solar-powered mole repeller that would, you know, thump the ground. But the thumpers that he bought took a lot of batteries, so he made a solar-powered version of it. Pretty much anything that you like, all right? And then, like I say, in winter, you come up with a proposal, and the proposal, you know, spells out what it is you want to do, what it's going to take to do it, so what are the resources you need, what do you have to learn, what are the challenges, what do you expect to learn out of this, and it also sets down very specific milestones. So, you know, by this date, I will have achieved this. By that date, I will have achieved that. And these milestones are set so that as you continue to work on your project, you can know, am I ahead of schedule, am I behind schedule, and so on. Because you don't want to get to the end of spring term and, you know, find out that, you know, you're 10% done with your project. On the other hand, you don't want to get to week 2 of winter and finish your whole project and it's like, oh, I guess I'm done now. So it takes some some dialing in, and that's part of what we'll do in winter. The other thing I'll just say is when I was an undergrad, all of my learning happened through projects, right? I went to class, I got decent grades, you know, I paid attention, I learned some nuts and bolts stuff in my classes, but the real sort of, you know, skill development, becoming a better programmer, learning how to think about problems, all of that was done, you know, in my own time with my friends, because we were always working on projects. We were always like, you know, finding new toys to play with and taking them apart and reverse engineering them and then trying to like get them to do things beyond what they were supposed to do and challenging each other with, you know, can you figure out how to do this, or, you know, showing off what we'd done to one another and so on. And that's you know, in my opinion, really where the deep learning happens, right? You need the technical details, you need to know what an associative array is and so on and so forth, but when you take this stuff and you go off and you do something that you're passionate about with it, that's when you really kind of conceptualize it. And the more you can do that, you know, I think the more you're going to learn and the more you're going to have to say when you get to an interview, right, for whatever. Do you think we can get summer internships after this year's classes? Yeah, absolutely. It's not at all uncommon that after this year of Clark, students go off, they get a internship, you know, doing some programming between here and going on to a university. So, and that's a really good thing to do. That's really valuable experience, right? Plus some income, which is always nice, and it just gives you another leg up, you know, in subsequent classes, and then later on, once you've got a bachelor's degree and you're going back into the workforce, if you've already got some work experience, you've got someone who can speak to your work ethic and so on, that just all helps. So internships are definitely nice. I don't know how it works right now with COVID, because, you know, everything is kind of wonky, but yeah, there's so, you know, normally I say career services, but, you know, online stuff. I'll do some digging around and see if I can post some things to check into. When I hear about opportunities, I usually post those on Canvas as an announcement and let people know about that. Like I say, things are kind of different right now because of where we are lockdown wise. Is it too late to apply? You know, there's no fixed guideline or you know, timetable for this stuff. A lot of the stuff is word of mouth, you know. Sometimes you'll have a friend who works somewhere and we'll hear about an opportunity. And there's no, you know, one place you can put in an application and, you know, automatically have applied for all possible internships. But there are a lot of places in town that will do, you know, summer hires for students who are pursuing a degree. Take a look around LinkedIn, put yourself on some local lists, and see what's out there, right? Polish up your resume, get some stuff in order, get yourself a nice Git repo where you can, you know, have your code samples available so you can put that on your resume and people can look at what you've been up to and so on. WSU applications for transfer. So I believe the deadline for fall is in January. So you can be applying right now. If you're planning to transfer in fall, go ahead and you know, hop on WSU's website, get yourself an account number, and follow the instructions for applying as a transfer student in computer science. And you know, I'm pretty sure you can do that right now, and then have it out of the way. All right. So yeah, that's just basic background on service learning projects, something to keep in mind. We'll talk about it in winter in more detail. And before then, you know, if you have ideas and you wanna kick them around, shoot me an email and say, hey, I'm thinking about something in this area, or hey, I have no idea what to do. Do you have any recommendations? And I can point you in the direction. So in the STEM building, the hallways are lined with posters from past years' SLPs. We don't have the advantage of being able to browse those in the hallway right now. But you know, if we ever get back to, well, I think we'll get back in summer. Those will be there. All right. Let's see. Any other questions? All right. So let's talk about awk. We talked about SED in a bit of detail, and SED was, you know, basically built around the idea of pattern matching and replacement. So doing edits on a file, basically line by line. So SED is the stream editor. Stream is a word for, you know, typically a file that's coming in character by character, line by line, and you're editing the file as it's coming through, right? So it's kind of like a batch mode operation. Awk is a little different. Awk is really kind of focused on within an individual line coming in from a file, let's do some processing, let's do some analysis, let's make some decisions. And so awk works like this, basically. Awk, program, and then an input file. Alright, so awk's the name of the command. This is a string which represents a program we want to run, and then this is the name of an input file. And if we don't name an input file, this just reads from standard in. And our program can be a string describing the program, and if we have, you know, a one-line program, that works well. If we have a more complex program with multiple lines, we might say, just like we did with SED, dash lowercase f, and then list the name of a file containing our program. And our program itself is a succession of lines, and each line basically looks like this. There's some pattern, followed by curly brackets, and some action we want to take if that pattern appears in the input line. And the pattern can be completely missing, which means, you know, we don't have to match anything, so we'll just go ahead and take this action for every line of input that we read. There's special patterns, so, you know, it could be blank. It could be the magic word begin, or the magic word end. Begin is a pattern that matches before we've read anything from the input. End is a pattern that matches after we've finished reading everything from the input. So we can do some pre-processing and post-processing with those. And there's other patterns that we'll talk about in a few minutes. Action might be something like print. And so let's just start writing some sample awk code. So here's a one-line awk program which says print haha. And there's no pattern specified. So for every line of input, this should print out haha. So I can say this is a test. Hello, 1, 2, 3, 4, 5, right? And everything that it reads, it responds by executing this program which says print hello. Print haha, right? That's a silly program, but you know, that's what it does. And if I run this on my bash RC, it prints haha for every line that it reads from that file. All right, so that's not terribly useful. It gets a little more interesting when we look at variables. So variables, we always have a few variables predefined for us. We have the variables $1, $2, $3, and so on. And these correspond to the fields on the record that is just read. And by default, fields are separated by spaces. We can change that, but by default, they're just space separated strings. And the first field is stored in $1, the second in $2, and so on. $0 is a variable that represents the entire input record. So it's all of these $1, 2, 3 concatenated together. NR is a variable which says what's the number of this record that I've just read. It's the line number, basically. NF is the number of fields. So how many words are there on the current line? And there's other variables we can use, but let's just play with these for a moment. So here's my foods array, right, with a name, type, color, and price range for different foods. So we'll pick on this for a few minutes. So let's write some awk programs. So if I say awk print $0, that should print out, you know, the entire line for each line that it reads from this file, and it's like a glorified version of cat, right? It just printed out the contents of that file. If I were to print $3, that should print out the third field from each row of my file, which will just be the color of the food. Right, so now I've got a list of colors. If I want to know how many of each color is present, right, I could take this and I could sort it, and then I could put it into unique-c, which counts how many times a line is repeated. So brown will be 1, clear will be 1, dark will be 4 because it's repeated 4 times, green is repeated twice, and so on, right? And then if I want that to be in increasing order of frequency, I can pipe that into sort-n, and now I know, you know, how many times different colors appear in my menu of food. So if I want to color coordinate my meal, right, I could choose a color scheme like this. That would be an interesting thing to do. So this is a really simple program. Awk, don't worry about matching a pattern, just print out field 3. Alright, if I print NR followed by $0, $0 is the whole line, NR is the record number. Now I have my file, but with a line number in front of each line, which could be useful. Right, now I could write a C program to do this, right? Just you know, call fgets to read a line, do printf to print it out, keep a running variable that shows my record number, increment that, print that out with a %d, followed by a %s, you know, for the string itself. But this is really easy, right? Alright, so there's my bash file with line numbers in the front. I can print out the number of fields on each line, and I can see how many words I have, basically. Alright, so this is all 2 words, this is 3 words, and so on and so forth. Alright, awk also understands arrays, and it understands associative arrays. And there's no funny syntax to worry about like there was in bash. We can use an associative array simply by saying, you know, array name bracket key equals value. And that will store this value associated with that key in whatever this array name is. And if there was, you know, a previous value with this key, it gets overwritten by this new value. If there was nothing in the array indexed by that key, now there is, and it's associated with that value. So associative arrays work pretty directly. We can do if statements. So we can do, you know, if some condition, do some stuff. We can do an else, do some other stuff. We can do while some condition, do some stuff. And it starts to look and feel very C-like in syntax, but without some of the annoying parts like semicolons. And we don't compile it, right? It's interpreted. All right, so let's play around with some examples. So here's a really simple file, F1. Begin says, you know, this pattern matches before we've read anything from the input. So in the very beginning, it's going to execute these statements. All right, and this statement basically says, you know, print out this header and then print out, you know, some underscores to put a visual separator. And then the body of the program just says, you know, what we did before, print out the number of the record, a space, and then the whole field, the whole set of fields. And then at the end, after it's read the last line from standard in, it will execute this statement which says print out the total number of records and print out the value of NR. So if I run that, I'm doing -F to say my program is in this file F1. I'm feeding it foods, and you know, now I've got the contents of my file, but with a nice little header up here in the beginning, and a tally at the bottom of how many records there were. All right, here's a pattern which uses a length function, and it basically says if the length of the first field is less than or equal to 5. So this is like a string length, right? So look at the first field, which is, you know, the name of our food. So apple, banana, Oreos, and so on. And if that field has a length less than or equal to 5, go ahead and print out the entire contents of the field. So this will subset our food list based on foods with a name of 5 characters or fewer. So it dropped bananas and hot dog and coffee, but it kept, you know, Spam and corn and peas. And we can do different formats, right? So if I use commas, it automatically puts some space in between things. If I just list things next to each other, it prints these out without any spaces in between. So this will print out the number of the record, right, the line number, followed by a colon, followed by the actual record itself. Right, so we've got a nice controlled output like that. All right, another pattern we can use is this alteration kind of thing, which looks like start, comma, end. And the way this actually works is if this start pattern matches the current input line, it will go ahead and it will, you know, execute these instructions. and it will keep executing these instructions on every subsequent line up to and including when this end pattern matches. And then after that, it will stop executing this until the start pattern matches again. And if this matches, then it will start executing these instructions up to and including when it reads a record that matches the end pattern. But the most common use for this is something like this, where we just say, you know, starting with where the record number is 3 and ending after the number of the record is 6. And so this is a quick way to print out, you know, records 3 through 6 from our file. And I'll print out the record number, a colon, followed by the contents of the file. And if we run this, right, we've got records 3 through 6. All right, so someone asked, can an awk program be executed from within a C program? Sure, you can run it with a system command if you want to do something like this. You can run it with popen if you want to just direct standard in, or read standard out from it, or you can open it up using some fancier stuff to do two-way communication. So creating a pair of pipes, doing a fork, doing an exec, and then you can send things to it and get stuff back from it also. And keep in mind, Bash is a C program. So if I can run awk from my command prompt here, I can definitely run it from inside C because, I'm not in the operating system here. I'm simply running a C program, right? And when I say, awk, somehow my C program is causing all of this stuff to happen. So that's a little Inception-ish, but in a good way. Alright, we can also do things like this. I have no pattern specified here, so this set of instructions will run on every line of input. But I'm doing a regular expression match here, so if I put in a variable and a tilde and then specify something inside slashes, this is treated as a regular expression. And, I'm specifying an exact pattern here, so I could just do, equal, equal. But I can do a whole regex if I want, and wildcard things. So I'm going to look at field 4, and if it's equal to cheap, I'm going to change field 4 to say, under $2. Otherwise, I'm going to change field 4 to say over $2. And then I'm going to print out my entire field. So if I do this, right, it's changed this fourth field. It changed it into something with spaces. That's okay. It'll basically do whatever you tell it to do. All right, so this is starting to look more like a program now, right? I have an initialization block triggered by the pattern begin, which sets these two variables equal to 0, and this script is going to tally how many times I see the word expensive or I see the word cheap in my input records, fourth field. So my main program fires on every line of input. So if the fourth field matches the regular expression cheap, then I increment this variable cheap. If it matches expensive, then I increment this variable called expensive. And then at the end, after it's read the last line, I go ahead and execute these statements, which are just a pair of printf statements. Looks a lot like C now, where I print out the value of these two variables. Right, so that's a tally. And I didn't get any output in the middle because I didn't say to print anything in the middle. Right? In the middle, all I'm doing is bumping up some variable values based on some patterns. And at the end, we actually do 2 lines of output. Alright, here's a good old associative array. So I'm going to use the second column which tells me the type of food, so fruit, cookie, drink, etc. And I'm going to make an array called foods. I'm going to set foods bracket 2 to its current value plus 1. And just like in bash, if there is no entry foods bracket $2, it'll be treated as a 0 if I try to do arithmetic. So when I read my first line, foods, this $2 variable will be fruit. This will say foods bracket fruit plus plus. So it'll read the current value of the foods array indexed by fruit. While there is no such key in that array yet, so it'll read as a 0, it'll increment it to a 1, and then store that back. So now the fruit entry of my array will be equal to 1. And then when I read the banana line, it will say foods bracket fruit plus plus. Well, it'll read it as a 1, increment it, write it back, now it'll be 2. So this will build a tally of how many different types of foods I see in my input file. And then at the end, after the last line has been processed, we have this for loop. So this is structure from our homework H. For food type in foods, well, this says for every key that's associated with some value in this foods array, let's print out the key and then the value associated with it, foods bracket that key. So if I run this, right, I've got an index of how many times each type of food appeared in my file. Right, so really simple associative array action here. Something that would be pretty intense to try to write in C. Right, taking in your file and breaking it up, figuring out what that second word is, and then trying to tally that, you know, with some arrays, and doing your string comparisons and searching and all that kind of stuff. And this is pretty straightforward. All right, here's a slightly more embellished version, right, where for each record that I read, I iterate across all of the fields. So item is the number of the field, and I use $item. This is going to be, you know, the first field the first time through, the second field the second time through, and so on. This is giving me each word from my input file, and it's setting the value of this counts array at that word, you know, indexed by that word. It's incrementing it. This is counting how many times each word appears in my input. And then at the end, I'll simply go through and for each word that I tallied, print out the number of times that it occurred. Right, so there's how many times different words appeared in my foods index. And here's the same program, but I've changed the shebang. I've put a shebang at the top, and instead of bin bash, my shebang is user bin awk-f, which says, you know, if I just type the word index, it should run this program, that's awk, and it should feed awk all of this. That's the program. And so if I just say index foods, right, it runs that awk script on my foods file. Right, so I can run this on Wuthering Heights, and I can pipe it into sort-n, and there's the number of times that each word appears in that input file. So the and are the most common, and I saw Heathcliff, main character, and Catherine, pretty common, and then dropping off. Right. So this is you know, words instead of phrases, but you could do this for phrases also, and that's homework H, right? and pretty dang fast, right? Definitely faster than when we ran our homework 8 on test 4, because, you know, awk is written in C. Yeah, it was way faster than mine too. All right, got a couple of minutes left, so let me just show you a few more examples. This is an awk program, but it doesn't actually process anything from an input file. It's a simple for loop that runs from 0 through 9 and just prints out, you know, consecutive integers. So I can just say awk-fs1 and, you know, prints out some numbers. This is an awk program that calculates the sum of the first 10 integers. So a for loop from 0 through 10, add x to a running sum, and then at the end of my loop, just print out that sum. This is an awk program to generate prime numbers, right? This is my hello world. And, you know, it's all done in this begin statement, because there is no file being processed even. But, you know, here's a loop where I look at odd numbers from 3 through 999, see if it's divisible by 3, set a composite flag, right? And actually I don't use this x at all. But you know, loop through all possible divisors up through and including the square root, and if my number is divisible by the divisor, set the composite flag. At the end of the loop, if the composite flag is clear, then my number was prime. So we can run this, and you know, there's a list of prime numbers. So this is like an interpreted version of C now, right? We don't have to compile, we don't have to declare types of variables, and so on and so forth. But it's you know, a whole lot more comfortable. Yeah, that x equals a over 3 was bogus. So you can do a lot of things with awk, right? Mostly we're doing it to process input from a file, but you know, we can use it for simple programming tasks as well. And awk is one of those things that, like, if you never knew about it, if you never knew how to use it, you would get by life just fine, right? But if you know how to use it and it's in your bag of tricks, you'll find yourself using it more and more probably. And it's something that I just use a lot when I'm writing scripts. It's a really quick way to take apart, you know, output from a file and so on and so forth. All right, so let's play around with grep tomorrow. We'll do some interactive exercises as a class. We'll work through some of the sample problems I posted, and then Friday we'll do some review. All right, have a good one. I will see you next time.